Originally, the punching bag with a mass of 20 kilograms is moving towards you at 3 meters per second. And after you punch it, it is moving away from you at 5 meters per second. Your hand pushed on the bag with a constant force for 0.7 seconds. Create a momentum impulse bar chart and or an equation to represent the scenario. Are the momentums the correct direction? Are the sizes the correct size? And then calculate the force you pushed on the punching bag with. Okay, so these first two questions are mostly just, I want to know, are you paying attention to how big you're drawing things in which direction? Those points are not actually worth anything. Instead, I am looking more for, did you draw the bar chart correctly? And then those two questions are more of a self-check. So the first thing is the momentum of the punching bag before it's getting hit. It doesn't matter if you make it positive or negative as long as everything else kind of matches. So, for example, it's moving towards me, which I would say in this picture, moving towards you is to the right. So I'm going to say that's the positive direction. And then after you kick it, it's going to go away from you, which is going to be the negative direction. All right, so originally it was moving with a momentum that is its mass, which is 20, times its velocity, which was 3. And after, the momentum is going to be moving away from you at 5 meters per second, and the mass will still be 20. So that's 20 times negative 5. So that means originally my momentum was positive 60. So I'll just draw it that big. And after you punch it, it's going to be negative 100. So that means that that will have to be bigger than the original momentum because it's going faster. Now, remember for this part, and this is the part that a lot of people mess up on, is when you add these two together, it needs to be equal to this one, which means that if I have a positive 60, I'm going to need a really big negative impulse to be able to make it equal to negative 100. All right, so let's go ahead and figure that out and figure out that force. So to write the equation for this, I'm going to just write it as positive 60 plus some impulse, I'm going to use J, is equal to negative 100. And so to find J, or my impulse, I need to subtract 60 from both sides. And just be careful here, when you have negative 100 minus 60, that's going to be equal to negative 160. And then once you have that, then you can remember that impulse is equal to force times time. And because my impulse is negative 160, that'll be equal to force times the time, and the time is 0.7 seconds. Divide by 0.7 on both sides. And I get a negative 228.57 Newton force. If you have any questions, let me know. And in summary, the main thing that you're paying attention to is making sure that these three things, when you add up the two on the left, it'll be equal to the thing on the right. And make sure that you're paying attention to which ones are positive and which ones are negative. And then just don't lose those negatives when you're adding things together.